And if you and let's say if you cut here, and you see on the side, you see something like that, yeah. And inside here, in this surface here, in here, you have a sinter material. Sinter material.
What is new?
Is this silver powder compressed
I see.
a lot,
Да, серебряный порошок.
and they have a very silver called. Oh yeah, okay. It gives we call silver powder sintered. I don't know what's translation for that. Is this everything like a sandwich? You press a lot, and you this silver, let's say, yeah, but it's not silver like the metal here have silver. If you make that powder, you know, it's a powder, and then you press everything together, you have a lot of the area from this. If you make some stripes with this powder, it's not. If you press so much, it's not only powder. It's really like you can have really a piece of that. And here you see a layer from this powder compressed, yeah. And then the area, the surface area that you have is huge, because you have a lot of. And then the contact, if the mixture comes inside, it's like if you have a sponge, you know. Yeah, and then you have a very good.
Серебряного порошка. И очень хорошо это. Все тепло.
Это в какой системе такая трубка используется? Вот самый последний, самый низкотемпературный.
And then you have a good contact from the mixture. You have the mixture coming inside and then going outside. You're cooling, and you have this a good contact surface in between. You have really a huge. Let's say at low temperatures, it's very important to have a very big contact surface area. Yeah. And normally, if you are now here is 0 Celsius. You put that here, so yeah, and press. You think, okay, here should be 0 Celsius as well quickly. At low temperatures, if you have here 10 millikelvin, you just put that here. This thing here could be at 30 millikelvin. Because just the contact area, the contact area is not good enough.
Вот в этом случае очень маленькая площадь контакта, и он будет там.
In one surface gas going only in one direction or in another also? Only in one direction?
No, one gas coming down. Let's say here is coming down. The gas from outside, yeah, and from inside is coming in. Up. Yeah, you have to imagine. You have the tube. Think about the tube. Yeah, the gas they come down. Let's say the gas they come up. That's opposite. Outside come up, and the inside come out. Yeah, and then you cool down the mixture that's coming down with the gas that or the liquid. Yeah, they coming up. Yeah, and in between you have this sinter material to give a very good thermal contact.
Нет, вверх идет жидкость, и вот то, что надо охлаждать, но оно все равно еще холодное, и оно охлаждает тот газ, который идет вниз. И вот как раз контакт между ними, это вот сложная поверхность там вставляется вот из этого серебряного порошка.
And there's not only this heat exchanger, these discs that you have there. You have 5 discs, and there's also double wall, let's say, in the silver material. It is a sinter material, silver material inside. That means what's coming down, yeah, is helping. What's coming up is helping to cool what's coming down. But it's in discs. This is 5 discs, yeah, and then this is a little bit, let's say, thermically isolated, because if you have that, you are not. Yeah.
And then it hits what's going down, yes?
Say again.
Then it hits what's
Not
going
hits,
down.
cools.
Yes.
What come up, cool what's coming down. Because
cools when what is going down. Cools or hits?
No.
Cools.
What you're pumping out is colder than what's coming inside. In principle, so we are pumping is colder. Then what's coming out is cooling what's coming inside. At the end, the coldest is in the mixing chamber. Yeah, but you have to imagine you pump out. Let's say let's say it's only a very, it's not really very good to speak that, but I can make an approximation. For example, this phase here, yeah. And that these under these steps we call continuous heat exchanger. This is a long one, looks like a coil, yeah.
Теплообменник.
And then they have the other discs, 5 discs. We call steps heat exchanger. And that was for many years.
Спросите, почему они 5 ступеней выбрали?
Why 5?
Is this that, let's say
What
we
is connected with? Why?
why 5 and why not 3? If you have 3,
Why not 6?
I tell you, money. You can put 6. If you put more, normally the temperature will come a little bit lower. Yeah. I have one system with 6, yeah, and I could achieve 5 millikelvin. Yeah, but every disc costed a lot of money. Yeah, and the Oxford,
because it's from this specific material.
yeah, and the Oxford said, that's why Oxford said Triton 200. That means in principle 200 microwatts at 100 millikelvin. In principle we can have also Triton 400. Yeah, and by the 200 you could achieve 265. Yeah, that means we could sell for more money because this thing is now about money. Everything. Of course, you can tell why you don't put 10. Then you have a low. Of course, you have a limit. You cannot go below, let's say, 2 millikelvin. You have a limit. Yeah, but you could make 10, but then it's much more expensive.
Нет. Сами диски дорого стоят.
Диски вот из
Да.
The temperature and power. Yeah. If you put more, you have probably the 400. In principle, yes and no. Yes and no. The difference is a little bit something different. but it's right. It's also with heat exchanger. Is it something you cannot see? You see 5. But it's not 5, let's say. But optical looks the same. Optical looks the same. Optical looks the same, but it's not the same.
And
Yeah.
how should we clean these discs?
No, you should not clean. Why clean?
Оборудование там, чё,
You shouldn't go inside. You see, we have very good experimentalists that can clean everything.
Just should go with
I
water.
told you about robot with hitting by a hammer on
No
hands.
cleaning. No if you put water inside, let's say, or put alcohol inside, you damage the. I have one customer.
алкоголь.
I have vodka. No, I have one customer.
No vodka inside. Buy to lose a good product.
No, I have one customer. They have a problem, and in other systems, completely different system. They in the wet systems, yeah, we use oil pumps to circulate, yeah. And this pump, they never change the oil. Yeah, you have to change. Normally, oil pump you have to change. It's like a car. Normally, you change the oil from your car. Yeah, the guy never changed. After 10 years, part of the oil begin to migrate inside the system. Yeah, because he never changed. The oil was really bad and beginning to migrate because he makes also a lot of mistakes. He make under pressure in the system and.
Здесь нет, он про другую рассказывает в качестве примера.
He put anyway. It was a customer mistake, and he put oil in the heat exchanger, yeah. And then he thought, oh, how can I clean that? And then he put alcohol inside, yeah. And he could remove the oil, yeah. But after that, he could not more achieve 10 millikelvin. Yeah, he could cool down, but I think the lowest temperature was 40-45 millikelvin because you damage the sinter material as well. Yeah, first the oil damage, and second the alcohol damage as well. Yeah, and then you cannot achieve so lower temperatures. Yeah.
Скорость охлаждения, где самая высокая? Сначала, в конце самая низкая скорость охлаждения, самая медленная.
What about velocity of different stages of cooling down? Which stage working for the longest time? First, we start with
Pulse
this
tube.
pulse
Pulse
tube.
tube.
How long normally does it go?
You mean now about long time?
Long
work?
time.
I mean, how many years?
No,
you're
no, no,
speaking
no,
about
not
that?
years. We want to cool from room temperature
Yeah.
power system down to 10 millikelvin.
Yeah, yeah,
For the beginning, start this pulse tube,
yeah.
and it works for a certain time.
Let's say
to achieve 4 Kelvin.
Yeah,
How long?
let's say we tell about from room temperature to 10 Kelvin, take something like 12 hours. The manual is written 12 hours to 10 Kelvin. And then after that you have to pump the pre-cool line, because your circulator have to put, you pump 1.5 an hour. That means in this 1.5 an hour nothing happens. Yeah, you just pump out, and then you begin the condensation. And take normally 3.5 an hours to cool down to below 100 millikelvin. The last millikelvin, let's say between, let's say